Huh? See it? When it's a normal distribution. Because if it's just some arbitrary distribution, who the hell knows what percentage is where? It could be any freaking where. But if it's normally distributed, I know a ton about how it's shaped. I know that the most of it's in the middle. That's why I can be so precise on this chart about, okay, if you're here, you got exactly this much area below you, because I know it's normal. Okay, maybe. So, oh yeah, look at that. If you turn it on, it's amazing. So let's do a couple of quick examples, and then we'll do this. Ooga. Okay. All right. So if I gave you the problem is normally distributed. So a big thing in statistics is, I'm going to say this a few times, if I know the problem I'm working with is normal, that kicks ass because I have all the answers for any probability question. So if I have a situation where I'm not certain, or if it doesn't say, there are things I can check to see if it's normal enough. And that's what we're going to start doing in chapter 7, and then there's various other things that we can check to see if it's normal enough to use this, right? Maybe, because this is all the freaking answers. Yummy. I just have to know how to use this and know when I can use it. So if I just say it's normal, kick ass. I know I can use that chart. Let's say the mean is 112.7, and the standard deviation, let's say, is, what is it, Jeff? Leave me alone. 17.5. Sure. Looks yummy. Stop saying yummy, Jeff. I will try. Can you draw that, what I have so far? Can you draw that picture? Not really much to it yet, right? What goes in the middle? Yeah, so 112.7. This doesn't really show up yet. I mean, it kind of determines how fat that poor little dude is. We don't have to really capture that on this. It's just a quick visual anchor, so it doesn't have to be perfectly scaled at all. And let's say the question is, what's the probability that x is less than 115? Can you put that on the picture and then shade where the answer would be? So hopefully on one level this feels a lot like a uniform. I put the question on the picture and I shade, because the area is the answer. The big difference is I ain't got no frickin' geometric formulas for a side of my box melted. I don't have an area formula for a melty box, right? If your geometry teacher did show you one, you gotta show me. I want to see that shit. So where's 115 go? Please, dear God. Yeah, up here somewhere. And then I'm going to shade where? Below. So right below 112.7, what could I put? What would I put here?
0.
Why?
0.
Because that's the z-score for the mean, always 0. How far away from the mean is the mean? 0. Right? Where are you? I'm right on top of myself. I'm mean. 0. What do I have to do with 115 before I can use the chart? Yeah, because there's a z-score chart. So let me see. I always try to see if this is going to be helpful at all. I guess I'll write it up there too. I normally give you an x score, like the 115, right? We change it into a z-score, and then we look up the area in the chart. So this would be the z-score formula. That's how I change it, right? Take an x, I'm given an x, I change it to a z, and then the chart, I look up the area. That's the standard kind of traditional z-score problem, right? And this is what we have to kind of really know well, very quickly, because you're all insane. You took this less than 4-week course. So how do I change that 115 into a z-score? I just do How do you change that 115 into a z-score? Yeah, 115 minus 112.7. So that's how far apart they are, period, but I need to turn that into number of standard deviations, so I divide by 17.5. Oh, let's see. 1, so I don't know, it's like around 0.1 maybe?
0.1314.
0.13?
Yeah.
Now, couple things. All right. Do you guys notice how I have identified what formula I'm using? So that I know when I get here, it's just a z-score. If you don't put that z there and you do the formula, you're gonna circle this and say the answer is 13%. Is that a percentage? It's a z-score, right? So be nice to yourself. Identify what the hell it is you're doing at that moment. Because that looks like a percentage, like 13%. But we know it isn't, it's a z-score, so I still have to look it up. So try to look it up on the chart, don't say anything out loud. See what you get, write down what you get, and then we'll compare. If you weren't here yesterday, here's how to read this thing. Z is 0.13, so it's positive z-score.
Was anyone here yesterday?
I mean, you know, relative to the class, smartass. Okay. I always like to identify my smartasses because I feel a kinship. So, my z-score is positive 0.1, and then the second decimal place is always up here, 0.13. You guys see that? That's how to read this chart. That's how they're able to put it all kind of concisely. So 0.13 gives me an area of 0.5517. So that's the answer. If you wanted to, you can write it as 55.17%. Kind of makes sense, because what's the probability is less than 112.7? 50%. So the probability is less than 115, and that's not even a step up. It's going to be a little bit bigger than 50%. So see, that's how you can make sure it makes physical sense. I like it. Okay, maybe. So let's do one more, and then I'll hand out this handout. Same situation. Mean is 112.7, standard deviation is 17.5. But now I want the probability that it's between, what, Jeff? I don't know, 70 and 90. Yeah. Did we finish that one? Yeah, we did. One mistake that people don't make as much anymore for some reason, which is nice, but somebody would do like 70 minus 90. That doesn't mean anything. Z-score is always relative to the mean. So you have to make two different z-scores for each. One for each, so two total. Negative 2. You guys getting that there for that one? Negative 244. So yeah, you have to tell the calculator what the top is because it doesn't have eyeballs. That'll be the TI 3000, and then we're all dead after that. Negative 2.44. And then for 90, yeah, so you got to find out where that data point is relative to the mean, because then the chart knows how much area there should be below that place. The further away from the mean I am down, for example, the less stuff there will be below it. Is everybody with this so far? Sort of? A little bit? Okay. So I got this z-squared negative 244. What are you guys getting for 90?
1.3.
Negative 1.3, yeah.
Yeah.
This is 1297, so of course up to 30. Kick ass. Now look those up in the chart, see what areas you get. So when you look up negative 244, what are you guys getting?
0.0073.
Yeah, 0073, negative 244, 0073. You look at negative 1.3.
129.
I got this here. Is that all right? 0968. You guys all right? You guys all right? Oh, no, Jeff. 0968. So how do I get the area that's in the middle? Subtract those. It makes physical sense. That's crazy. It's not allowed in math. So then when you subtract those, what do you get?
0.0895.
Yeah, 0895. Come a 9. Rah, that's a 9. Poor little thing. Make sure you do circle your answer, because very often there's all kinds of stuff happening. So this, I mean, you don't actually have to do everything I did up here, but this will help you. Why be mean to yourself? The stats is hard enough already by itself. Show yourself where things are. You know the answer should be kind of smaller, right? It's not going to be more than 50% for sure. I put these down there just so when I look them up, I know where to put the number. It's below the z-square I looked up. So what does this number mean exactly? What's that number right there mean?
What's the area of?
No, areas are up there. What's this number mean? Okay, so what's it mean for this?
The number of standards.
Yes, so it's 1.3 standard deviations from here down to there. You with me? All right, I like it, maybe, no. So this is not a good enough answer on a test when I ask you, but the z-score tells you where a data point is. And if you think about it, if a z-score tells you where it is, the chart makes sense because as I go further away, I have less and less area. And you see that on the chart. If you go -2, -3, less and less area below me. As I move up, I get more and more shit below me, right? And where on the chart are the numbers changing fastest? There's places where they barely change at all, and there's places where they change really quickly as you move from one z-score to the next. In the center, because that's where most of the stuff is. If I take a little step here, bam, I just picked up a whole bunch of shit. But down here, if I make a little step, bam, I didn't pick up much of anything. Okay, maybe. Everything I just said is not needed to pass this course, but everything I just said makes all this stuff make more sense, hopefully. So, let me give you this. This would have been the quiz if I had enough time to do like a quiz on this one. But I figured if I were you, I would have mutiny if I tried to do that.
Screw you, Jeff. Mutiny.
went from 0.23.
Oh, yeah.
So
All right, so give this a try.